let's continue. So what Peter has proposed, the two next speakers, or not they themselves, but at least the companies they are working for, have already done. So both of the companies, LONGi and Trina, have multiple 50 gigawatt plus module factories. That's levels beyond what many countries or regions even install per year. So I think that's a different dimension, and it will be great to have now Max Lee speak on behalf of LONGi. Dr. Max Lee graduated from Shanghai Institute of Ceramics at the Chinese Academy of Science. He joined LONGi Solar in 2016, so pretty early on, and is responsible for product marketing, and he has planned and promoted LONGi's project-based products along the evolution. So the HIMO series 1 to 5 was all he has been working for. We're very happy to have Max with us and telling us a little bit more on LONGi's strategy at the moment, focusing on 182 millimeter. Max, the floor is yours.
Okay, thank you for your introduction. I'm Max Lee from LONGi Solar, and my topic is review of module size evolution and the advantages of the M10 cell based module. The first part is the technology and size evolution of PV module. You know, the LCOE is the first principle of PV technology. We use LCOE to achieve a balance between the high efficiency, low cost, and better performance. We should consider about the module cost, also the BOS cost, and also the energy yield performance, and the last is the module reliability. Based on LCOE, the cell module technology and the size of the module evolution, the technology reduced the LCOE gradually when, such as the mono silicon wafer, and the PERC cell technology replaced the BSF cell. In the module size, half cut and the MBB plus multi-bus bar became the mainstream module technology. Also, the bifacial module dominates the utility power in the utility power plants. The size development is based on the reduction of the PV cell and also the wafer in the early time. And after the 158 millimeter specific appear, we consider more about the terminal requirements and the design of the PV module. And this is the evolution of the cell efficiency and the module power. In 2016, the efficiency of the PERC cell is 20.8, and now it comes to the 23.5%, and by the increase of the cell efficiency, also we use half cut technology and the 9 bus bar technology. Also, by introduce M6 wafer, the power, the front side power comes to 450, and by using the M10 wafer, the power will come to near 550. But we don't think it's always the larger the better. And the M10 is it launched after we considered every details of the module design and the design of the PV station. So for so the next generation products will be based on high efficiency cells, and the power of the module will come to more than 560. Now the high junction cell costs very much, maybe 6 cents higher than PERC, but the TOPCon technology, TOPCon cell will for TOPCon cell is about less than 2 cents. So we think TOPCon cell is more realistic. Now it's an example. The bifacial PERC module. LONGi launched the bifacial module in 2017, and since then we verified the bifacial gain and reliability of the bifacial module by a lot of third party pilot projects around the world. So it's reliable and can generate more power. And 063 to 6005, and in 2019. When we use the M10 M6 wafer, the module size increase, so we adjust B-side widths from 30 to 35 millimeter, and in order to match the M10 module, we just modified the structure and the weight per meter of the frame. And another example is the Crackless smart soldering by LONGi Solar. You know, if we use small gap, the module efficiency will be higher. By using this technology, we increased the module efficiency by 0.3% compared with the conventional multi-bus bar products. Also, using this, we use the integrated ribbon. The triangular section of the ribbon will maximize the utilization of the front light, and the flat section will achieve dense soldering with low stress. You can see the photo. Using this technology, we can avoid crack by lamination. And then the logic of the wafer side increasing. As I talked, firstly, the PV industry, just like the semiconductor industry, the manufacture of the chip cost very much. So in order to make 12-inch chip, we can bear hundreds of micrometers increase of the silicon wafer. But for PV industry now, the cost of the PV cell is not very much. Just count the 7% of the cost of the PV station. So it's no longer the key factor of the PV industry chain. So we should consider the more of the about the terminal, the design of the PV project and the design of PV module. But in the semiconductor industry, the increase of the wafer will not influence the package and the terminal section. So we should think about the optimal module size or not the optimal wafer or cell size. Something we should think is the many limitation as the high thermal loss of the internal inside the PV module and the complicated handling and system compatibility. So the launch of the M10 specific just based on the glass the capacity of the PV glass and the PV PERC cell. Using this specific, the module size will just increase the module length and the width will just increase to 4 to 5%. So most of the rooftop we can change the M2 module to M6 module. So we can maintain the same number of the module. Then the total power is increased and also the DC-AC ratio. So the cost of the BOS cost is reduced. There are two sides of the M6 module. Just the 60 cell of the module is less than 1.8 square meter, and the 72 cell module is less than 2.2 square meter. The 60 cell module, for the 6 cell module, the weight is less than 20 kilogram. And the M10 we think is the optimal size with systematical thinking, just about product feasibility and cost and module reliability, and also system capability. Also considering the manual installation. Just for the cost, we calculate the cost of the silicon per watt for the M10 module and the G12 module. The M10 module will reduce about 10% of the cost, just because the wafer is of the G12 is thicker, and the larger module will result in more risk in the lifetime cycle of the PV station. So it's the review of the LONGi Hammer 5, also the M10 module. It is launched in June of 2020, and the first order shipment happened in September. And also Jinko JA Solar launched their M10 module at the same time. And in April, the Hammer 5 won the All Quality Matters Award of 2 Relent, demonstrates its power generation performance. And also in June, it won the Intersolar Award from its optimal side and the smart soldering technology. And in November, the total shipment of the Hammer 5 achieved 10 gigawatts. And that's next is the feasibility and reliability logic of the optimal side. The M10 specific comes from the thinking of the package. Using the door height of the container is from 2050 70 to 80. We should leave some margin and pallet, so the module width should be around 1,130, and we need the rows of the cell to be an even number. So if we choose the 6, the cell length should be 182. If the module is more get more width, we need to use another the other package method. So just if we use the portrait package, it is not convenient for unloading, unpackaging, and transport, and also is easy to falling. So it is a danger for the workers. And also the mechanical loading tests. The HAMO 5 of the deformation is less than 40 millimeter, and the oversized module, which area is more than 3 square meter. It had a more higher deformation and also the higher degradation rate. And to the dynamic mechanical load test, the HAMO 5 degradation, the degradation of the HAMO 5 is only 0.5% after 22,000 circuits of the test. But the oversized module only after 2,000 circuits of the test, the frame of the oversized module is broken. And also the window tunnel test. In the basic test, we found that its vibration acceleration of the oversized module is higher, and also the strength of the HAMO 5 is higher. And you can see the video. In the threader test, the HAMO 5 can pass the 60 meter per second wind, but the oversized module only will broken in 45 meter per second. Then is the Hall impact test. In this test, the oversized 3 of the oversized module all failed, and for HAMO 5 it will pass this test, and the degradation is less than 0.5%. It's just because the strength of the different kinds of glass. The glass with the width of 1.1 meter have the is 10% strengthened than the 1.6 meter wide glass. And for the junction box, the M10 module need 25 ampere junction box, and there is enough safety margin for the bifacial module. And to the G12 module, at least we need the 30 ampere junction box, and it can not be realized by one chip, but need two chips or two dials that will increase the risk of the failure caused by uneven current. And the hotspot reliability and the power of the PV module get higher either by add cell or add the or adding the current. The hotspot energy will increase. So it's so we don't suggest using too large module. And all of that review the LONGi lifecycle quality standard. We think more about the lifecycle quality by module design, also by choosing of the BOM material, also by the power generation. So well, we will stay in this module side. And the last part is the BOS cost and the boundary condition analysis. First is the manual handling feasibility. For one person, the maximized weight is around about 20 kilogram to 25 kilogram. But for two person, we need an index of 0.666. So the maximum for two person will be about 33.3 kilogram. So you can see the M10 module have in nearly this weight. The weight of the module is 32.5 kilogram, and the module nearly the overside module of the weight of the overside module will be nearly 40 kilogram. You can see the photos. It's very hard for two men to handle it, and it's also quite harder for one person to move it below. And this page I'll tell you which is why we use larger module can reduce the BOS cost. The first thing is for the cost of the rack and the foundation, because using by increase the length, also the width of the rack mounting system, we can reduce the use of steel and also the number of the foundation. So we also we can reduce this cost either by increase the string power, or also by increase the strength in one mounting system. And if we chose the similar length of the mounting system, for the extremely it can be 120 meters. So we have 8 strings of the M10 module, and also the 6 string for the G12 module. The cost of the rack is almost the same. The difference is less than one Chinese cent. Because of the high efficiency of the M10 module, it's the cost of the rack cost of the M10 module is less. And we also should think about the sensories adaptability. Not all the PV station is built on flat terrains. Also, some stations on the mountain, and also we have trees in the land. So sometimes we need longer mounting system for less cost. But also we need a shorter rack for the station in the mountain. And you can see the M6 and the M10 module is similar. The length of the rack can be around 7 meters. And also for the trackers, the tracker of the for example, the 1P tracker, the length of the 1P tracker should be around 100 meters. It can, so we can arrange 3 strings of the M10 module, also the 2 strings of the G2M module. The total power is quite similar, and for the M10 module, the total power will be higher by 10%. So it has it will reduce the cost of the tracker. And we should not only see the cost of the PV cables and the ohmic loss on the cable. We should also calculate it. So this is the black line is the total cost. You can see use the PV the 4 square micrometer of the millimeter of the PV cable. The current is about 15. We have the optimal total cost, and that is the IMP of the M10 bifacial module. Now is the BOS comparison on the 3 principles, like the same length of rack and the same installation cost of the different module, and also we use different cables to get balance of the ohmic loss and also the cost of the cable. You can see the BOS is quite similar with different module. Further increased module size will not bring us more value. And you can see by using larger module to reduce the BOS cost, we need to adjust the boundary condition. And by using the M10 module, this will the length of the rack and the total cost of the cable could not further be reduced. And in the next step, we need to use higher efficiency module that will help us to further reduce the BOS cost on these boundary condition. And in conclusion, we think the M10 module have the optimal module size is just about 2.6 square meter. This will we will both benefit from it on the reliability of the module and also the BOS cost. In the next step, we'll focus on the increase the efficiency of the PO cell. So that's my speech. Thank you.
Thank you, Max, for this comprehensive overview on LONGi's work with a focus on 182. We're now, I think, if there are any questions, because we're delayed, I suggest that everyone asks in the chat in written form, and Max would answer the questions there.